All right, good morning. Today we are talking about rate of change. Rate of change of a linear function. And rate of change is, yeah. Can I go with my locker and drop my notes back? Yeah. All right. So rate of change is a concept that you guys are starting in 8th grade, which is very, very cool. It is the entirety of calculus. So some of you will get to see me again in calculus, and all we talk about is how fast it's changing. All right, rate of change, how fast something is changing, and it tells us a lot of information. So rate of change is a ratio. What's a ratio? What's a ratio? Just a fraction. Yeah, just a fraction. All right, it's just a fraction. A ratio that shows how one variable changes with respect to another. It is a fraction or ratio that shows how one variable changes with respect to another. Now, we started yesterday graphing on the x and the y axis, and those are our two variables. And so when we look, we have a line that we were graphing yesterday. We can say the relationship between the x and the y when we compare how it changes horizontally and vertically. That's comparing the x and the y. Slope is written as a ratio. Oh, I forgot this part. On a linear graph, this is called the slope of the line. So we talk about rate of change is also the same as slope. They're two different things. Well, they're not different. Two things, different words, same meaning. Okay. Slope is written as a ratio of the vertical change, which is, we call the rise. Vertically, we're going up or down, how much it's rising or falling, to the horizontal change, which we call the run, between any 2 points on the line. So I want to take your two colors that you've got here, and they have a nice little example of this little line. We've got some points plotted on this line, and what we want to do is we want to say, hey, I want to know how much it's going up. This would be the rise. How much does it go up? And then how much does it go to the right? And that's what we call the run. We create these little risers and treads. They're stair steps. All right? And that's why when you have stairs, like in carpentry, the risers are the things that go up. And then you got the treads, that's the run you put your foot on. Okay? So you got risers and runs. And so again, we can say, hey, how much do we go up? So that's the rise. And then I like to say the running part is always to the right. So we have a rise and we have a run, and we have a rise and we have a run. So this slope, this rise over run, remains constant for any 2 points on the same line. Slope is written as a fraction in simplest form. Slope is written as a fraction in simplest form, which of course means we want to reduce. And the variable for slope is m, which is totally weird. So we use this letter m also to represent slope. M equals slope, which also equals the rate of change. They all are the same thing. Lots of different things talk about the same thing. That comes from the word modulus, which in mathematics is a thing that means how we multiply things. Okay. We have a couple different types of slope. We have a slope that goes uphill. This is an uphill slope. We call this a positive slope. It's going uphill from left to right. That is a positive slope. And then if I have a slope that's going downhill from left to right, downhill from left to right, what do you suppose that slope is called? Negative, absolutely. That is a negative slope. And here we have a perfectly flat line. What do you suppose the slope of that is? Neutral. Yeah, very good. It is a neutral slope, or a slope of 0, actually, because what's right in between positive and negative? 0 is right in between positive and negative. We're not going up, we're not going down, we're going 0 slope, okay? Totally flat is a 0 slope. I like to think about it as like a heartbeat, okay? When you have 0 beats per minute, they often call that a flat line, all right? So like you got an EKG, if you got 0 beats per minute, that's a beep, flat line sort of scenario, okay? Any medical enthusiasts? I love medical dramas. Okay. All right. Then we have a vertical slope. And a vertical slope is undefined. And I'll talk more about that later. A vertical slope is impossible. This is what my worst nightmare is. I have this dream right before the start of school every year where I'm in the car. And I've got all my kids with me, which is what we do every day. I drive my kids to school. And I have this nightmare, this reoccurring nightmare, that we get into this like off-roading, right? Can you see me off-roading? I don't know. Anyway, I'm off-roading in my Subaru. Actually, when I have this dream, I'm in some big giant Hummer. I don't know why. But I'm in this big Hummer with my kids, and all of a sudden, my off-roading excursion, I start climbing a mountain. And I start climbing this crazy mountain, but the mountain gets super duper steep. And I'm in my dream, my nightmare, and I'm like, this is so impossible. How are we not falling off, right? So it's that steep that I'm like, my car cannot possibly stay attached to the mountain. Okay, it's too steep. So this, I'm like freaking out. So that's undefined. It's just not possible. Okay. All right. So that's my crazy nightmare. Okay, so we want to be able to find the slope on a graph. And so again, M represents our letter we use to represent slope. And what we're going to look for today, and this is where you're going to use your two colors, we have the rise over the run. And this is a nice little thing to help us remember what is slope. What is slope? Rise over run. Rise over run. And so we're going to look here. I want you to use your two colors. That's why I asked you to get two colors. We want to find the slope of each line and write your answer in simplest form. We want to reduce it. And so when we do that, you can see I have a lovely line here, and we have two nice highlighted ordered pairs for us, okay? Now, when we find this, I always want you to start as far left as we can go. So I'm going to go to my leftmost point here, and I want to identify the rise. So I'm going to go from my leftmost point, and I want to find that riser. How much do I have to go up? There's my rise. Yeah, it's up 4. My rise is 4. And then I have to figure out the run. So from that point, I have to go horizontally to the right. There's my run. What's my run? 5. Yeah, 1, 2, 3, 4, 5 little boxes. And so if I want to write my slope is equal to the rise of 4 over the run of 5. Can I reduce that fraction? Nope, that's it. That's done, ladies and gentlemen. The rise is 4, the run is 5. That's our slope, rise over run, okay? Let's look at number 2. once again, to find the slope, it's equal to the rise over run. So I'm going to go, I see my 2 highlighted points there. Which one do we start with? The left side. Yeah, whatever's further left. So here we have the left point right down here. And I need to try to get to my other point. So I got to go vertically, rise. How vertical do we have to go? 6, I don't know. 1, 2, 3, 4, 5, 6. Yes, there's our rise of 6. And then I have to run horizontally. What's my horizontal run? Yes. So my rise is 6 and my run is 3. So 6 over 3. Can I reduce that? Yeah. What is 6 divided by 3? 2 over 1. Yeah, so just 2. So there we go. Our slope is equal to 2 because 6 over 3, 6 divided by 3 is just 2. Okay? How are you feeling? It's pretty easy. Today we're coloring. Happy Friday. Okay, let's look at 3 and 4 here. Now, I'd like you to notice on both of these lines, the number 1 and number 2, is this line an uphill or a downhill line? Uphill. It's going uphill from the left side of the graph to the right side. We're getting higher as we move to the right, so that's an uphill. And you'll notice that my slope was a positive value. Again, here on number 2, this is an uphill line, and our slope is a positive 2. It's a positive value going uphill. What do you think these values are going to be? Negative. Yeah, they're going downhill, so they should end up with a negative slope. Okay, so let's see what's happening. Again, we need to find the slope, and so that's the rise over the run. Now, I always start with my leftmost point, and to get to the right point, I have to go up or do I have to go down? Down, yeah. So to get to the next point, I have to go down, how many? 2. So that is down 2, negative 2. Since we're going down, the rise is negative. And then I have to go horizontally. How far am I running? Yeah, 1, 2, 3, 4, 5, 6. So that is a run of 6. So here my rise is negative 2 and my run is 6. Can I reduce it? Yeah, we can divide top and bottom by 2. And so 2 divided by 2 is negative 1. And 6 divided by 2 is 3. So we get a slope of negative 1/3. All right, let's look at number 4. Again, I want to find my slope, and it's just rise over run. So I'm going to start with the left side point. And do I have to go up or do I have to go down to get to the next point? Down. I got to go down a bundle here. So my rise, is it going to be a positive or negative number? Negative. Down 1, 2, 3, 4, 5, 6, 7. Down 7. Down 7. Negative 7. And then what's my run? 4. So negative 7 over 4. Does that reduce? Nope. Our slope is negative 7/4. Pretty good, huh? Any questions so far? What's the slope of number 5? Impossible, undefined. Impossible, undefined is the answer there. All right, so number 6, we want to find the slope. So I have a nice little fraction. I need to find rise over run. So I'm going to start on the left point, the leftmost point, and I got to go up or down? Up to find my riser there. My rise is 1, 2, 3, 4. And what's my run? 8? I think so. All right, so I have a rise of 4 and a run of 8. Rise over run, does it reduce? Yeah, we're going to divide top and bottom by 4. Dividing top and bottom by 4, I get a slope of 1/2, because 4 is half of 8. Ladies and gentlemen, will you keep working on the rest of those for me? Nice job. You do not have to use colors. You do not have to use colors.
I didn't find it, but I did.
Okay, beautiful. Thank you. Thank you. Just really important that when you're doing slope, the rise goes up and down. And the run, in my class, the run always goes to the right. Okay? So that's the top that goes up or down, and then the run is always to the right. And you will be far, far less confused. We always start on the left side of the graph. Should this be the rise? Is this a positive rise or a negative rise? Negative, good. Yeah. Oh, what is the slope of a line that is flat? 0. Okay, go ahead. I'm loving seeing the little stairs. Little stair treads is really good. Love it. Beautiful. Good job. You guys are doing excellent. I'm seeing negatives in all the right spots. Very good. So on this one, your run is 4, which is correct. But we're going down, right? Yes, good. Good, good, good. All right, awesome sauce. Give about 30 more seconds, it looks like. Whoops. Okay, beautiful, ladies and gentlemen. This line, number 7, is going downhill, so you always want to double check, is my slope negative? So you should be able to look very quickly and say, hey, this one should be negative, this one should be positive because it's going uphill. What's this one? Negative. It should be negative. Slope here is 0. Number 9 is -4 for the slope. -4, if you have -4 over 1, that's also perfect, -4 over 1. Here on number 11, is this a positive or negative slope? Negative. It should be a -5 over 3 for that one. Number 12, is this a positive or negative slope? Positive. Positive 3 over 2 once you reduce it. Positive 3 over 2. Number 13 is 1. Yeah, the slope is positive 1. It was 7 over 7, and it reduces to a 1. And on number 14, is it positive or negative? Negative. It's going downhill from left to right. So this is a -1 over 5. All right. Do you guys have any questions for me? This is so easy, right? Okay, here's the deal today. You have another worksheet that probably won't take you very long at all. I am going to be updating grades.